So yes, I'm gonna be playing with LEDs. So I have a couple. Blue, white, orange, and a couple mystery. Let's get started. So, first of all, if you don't know, every electronic thing requires a bit of power. So, I'm gonna get these alligator, which are all messed up and ready to explode, and hooked up to my power supply, which is the camera standing on. Turn it on. I'm gonna turn it down to 5 volts. I'm gonna limit the current to 1 amp, as shown here. Well, you can't tell with the amps, or you can tell with the volts. So, let's get going. So, these are live. Now, if you just plug this LED into the power supply, it's just gonna die and explode. And here, I have a couple of electronics to protect it from doing that. It's my simple light LED project. So if I hook it up to my 5 volt supply, you will see it will turn on. No problem. See? But if you just turn on this LED, as I said, it will just blow up. And I'm not gonna, blow up an LED just to show. So, let's take it apart, my project apart, and see what's in there that protects it. Okay, now I'm getting the last of the last screw out. Screwing the last of this out. And just like a capacitor, the electrolytic type, they are polarized. And if you don't know what polarized means, it means they only operate in one way. So, I've opened my itty bitty little circuit apart, which looks like, if I really wanted to, I could probably have more LEDs if I want. Let's give it a closer look. As you see inside, you see there's this big capacitor, and then LEDs, 1, 2, 3. Zoom out. And this one right here. And you see there's 1, 2 resistors inside of it. And these resistors prevent it from breaking the LEDs from over voltage, over current. As you see, I may have done this a little bit ago, because, look at my bad soldering job. Anyway, that's what's inside my little light project. And if you're wondering why did I put that capacitor there, it is so that it doesn't have to be in a steady input. It can just be any input that's DC, even AC I think might even work. I never tried that, using an AC input instead of DC. I don't have a diode in here, it probably wouldn't work. Did you know that AC actually hurts more than DC? If you put it on your tongue, which, why would you want to do that? If you, AC torture is like 5 volts, while DC torture is around 10 or 11 volts. Kind of weird, eh? Of course, the skin is going to be a lot higher, and why would you torture people with your tongue, by the way? I have no idea. So, that's what's inside my light project. Let's continue with the next project on the breadboard so you can see a little bit easier. As you see, I have now hooked them up to my power supply through here. This set of wire. So, how do we hook it up? First of all, we're gonna have to take one of these current limiting resistors, which these are 200 ohm resistors. I will probably do in a future video like how to identify the colors. Come on, focus. 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 There it goes. How to identify the colors on here. So this one is brown, blue, red, I think. see. Get that to zoom out just a little more. I'm on. Focus. 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 I don't think it wants to focus. Let me back it up a bit. There we go. So yeah, there's the colors of it. Right there. So we're going to use this resistor here. So what we do is we take the positive rail, we slip it into one. Doesn't really matter which one. Make sure that the ground and the positive never touch each other, otherwise your circuit won't work and you may or may not blow up. I highly do not suggest doing that. So yeah. Now on the negative end, you don't need to put a resistor there. You just hook the ground directly up. So if we take an LED like this one, oh, oops, this one is an LED. That one is a photoresistor, not a photoresistor, light sensor. So we take this. Oh, how to identify which side of the LED is ground, right? Because LEDs are polarized. Light-emitting diodes. So, first of all, the flat end is always ground. The whole LED is round, except for one side, and that one side is ground. This side. Can't really tell in video though. And usually the side that is ground usually has the most metal on it. So if you look, you see that one end of the LED has more metal on it, right? That side is the ground usually, and that smaller one that has the less metal is usually the positive side. And sometimes, if you have a brand new LED, the length of the wires are different. I think the longer end is the positive. So this is a brand new LED, so that means this one right here is the positive. Let's hook it up and see if it works. So we put the positive on the same one as identified, and then we put the ground to ground. Make sure you have the resistor to protect it. If you do not have that resistor, it will blow up and it won't work again. The magic smoke will be let out. If you don't know what that means, it's basically like this old thing that people with electronics say. Like with old IC chips, whenever you did blow like really old IC chips or integrated circuit chips, they will like release this smoke. And capacitors also will release this smoke when you blow them up. So let's turn it on. There you go, see? It emits this amber colored, orange colored light. So it works. Yay. Now we can vary the voltage. Like we can go as low as like 1.5. No. Turns on right about 1.6, and then we can go like, I'm gonna go any higher than 12 volts. That's 12 volts. And that's emitting quite a bit of light. So let's hook up more than one. Let's go. And for safety, I'm going to turn my power supply off. I don't want anything to short and pop or anything weird. I don't like weird stuff. And by the way, if you're after stuff like from episode 1, I probably will never do that kind of stuff again. So yeah, never expect that again. I didn't like it. I was being a fool, so yeah, there you go. So now I'm going to hook a couple of these together and see how well it works. See how many LEDs I can hook up. Now, I've just got a question. How many of these LEDs with these resistors, right, will take 0.1 amps? And I have around 25, so and I have like 100 resistors sitting here. So let's see. So I'm going to turn it on. Alright, they're both turned on, and it's drawing 10 milliamps around there. So I'm just going to hook a whole bunch of these up together until it starts dropping, which I'm going to set a current limit to there. And you don't do this with your power supply. I'm only going to do it for a short period of time. I'm going to short these two wires together. And that'll tell me what is the maximum amperage. The voltage will go to 0, and the amperage will go to max. There you go. I now have the amperage set to 0.01 amps. So I'm just going to keep placing LEDs until the until the LEDs start getting dim or the voltage starts dropping significantly. Which I had the voltage is going to be set to 5 volts. Alright, now the circuit is now at 5 volts. So now I'm going to place a whole bunch of these and see how many it'll take before the the voltage starts dropping or the lights start dimming a lot. Make sure not to short the wires. Here. And grab another LED. I'm going to place a white one now. White ones. Oh, whoa. Whoa, what is up with the focus? Focus, jeez. Sorry. Wasn't looking at the camera. Come on, focus. Focus. There we go. For some reason the camera unfocused itself. Sorry. And the next one, see? The white LED comes bright, turns on, right? Yeah, that is quite bright. So it is turned on. All three is still turned on. The white is quite bright. No, it's not burning itself. It's not getting warm. Now, for the next one, to prove to you that it doesn't work, I'm going to put this one LED backwards, and I'll show you. And then I'll put it back in the right way to show you that it does actually work, and I'm not just putting in a burnt LED in. So I'm going to flip it around. Put the negative with the positive, and put the positive with the negative. It does sound a bit weird, but... See? Now it's backwards, and that's supposed to be a white LED. Why do you keep on focusing? Focus. There. So you see? This LED is not turned on in any way. It is completely turned off. Now, if I flip the LED around, it will turn on. Give me a minute. See? That LED, here's the first white one, and here's the one I flipped around. Alright, so we have 4 LEDs right now. Let's keep going. Next, I'm going to put these, I'm going to put a blue one down. And, the LEDs will not be as bright, but you can have like 2 or 3 LEDs. You can have more than one LED on one resistor. The only thing is after more than like 3 or 2, the brightness starts going down significantly. So if you put like 10 of them on one resistor, it's not going to glow at all. None of them. So you would have to either put them up separately with different resistors or use a much lower resistance value, like 100 ohms or lower. Because these are 200 ohms. Yes, I checked them with my multimeter. So, there you go. Got a nice bright blue LED right there. That is not purple. That is blue. Just appears purple on the screen. Now I'm going to show you now what happens if I put more than one LED on one resistor. So I'm going to tack into the same one and go to ground. As you see, it works just fine, right? Both LEDs are working with the same resistor. As you see, they're both hooked up to the same plane, and the resistor's hooked up to positive. So you can have more than one LED on one resistor, but the only thing is the brightness significantly goes down. So I'm going to add one more to this one resistor. Oh, that one's going backwards. Alright. You may not notice on video, but as you see, it's flickering a little, right? When I plug in that third LED, you see my hand, it starts going like a reddish color. That's it's a white one. You see that these LEDs dim a bit, so that is my point. No more than 3 or 2, otherwise your brightness is going to start going down. You're not going to get your expected results. If you're like expecting for something really high, like you're expecting exactly 100 lumens and you use one resistor, you're not going to get 100 lumens. Lumens. I don't think it's pronounced lumens. Lumens? Lumens? Huh. It's a measurement of light, not if you're wondering. So the current right now is 0.05 amps and the voltage is 4.7, so I'm going to bring it back up to 5 even. Alright, I'm going to put another resistor down with the LED. It is definitely getting quite bright. And I don't even have my, it is during the day though. Why do you... Perhaps I won't put my hands in front of the camera. It is during the day right now, so there is natural light coming into my area, but I don't have my set light turned on. See? See, I don't have, that's my set light. Now I have it turned on. So, I don't think I need it turned on. There's plenty of light in the lab area. So I'm going to turn my stage lights off. Light, not very bright. It does the job. And yes, by the way, that is using LEDs, but I did not build that. But if you can go bigger with this. In fact, right now, if you're using a screen that's newer than 2007, actually LEDs are lighting up your screen right now. It's using these type of LEDs, side soldered or whatever you want to call it, and these are underneath your screen and they illuminate up or down or sideways. Usually it's the bottom or the top, and these illuminate your screen. And then I'll show you how bright they are. I might actually add a second set of light, and I might use that. Hook that up to a strong battery. Alright. Oh. Put it in backwards. Don't put it in backwards. And by the way, these LEDs will not explode if you put them in wrong. Huh. Huh, I think this LED is actually dead. The current's not high enough. Now they may get a bit warm if you have the voltage high enough. If you have them really high, like you're abusing them, then they'll get really high. Alright, I'm going to bring the voltage up again, because it keeps dropping a little bit. Make sure. Yeah, that isn't a LED. That would have done something. Alright, now I'm going to put one more LED in because I think this last LED will make the voltage drop. Like, beyond me just bringing it up again. Because right now, if I take all these current resistors off, the voltage goes, oh, 5.2. Okay. I thought it was around like 9 or something if I took them off. So I'm going to take, oh, put the resistor. Duh. Derp, 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 derp. No one gets me, does he? Oh well. Alright, so this is going to be the last one I'm going to place. And then I'm going to show you the screen LEDs that I got. And I got these LEDs right here. Focus, camera. I got these LEDs, which here's my hand. These came out of a 7-inch screen display. And it's about the same size as my breadboard. I'm going to place it down. See? Here's my hand. So, it's quite long, and it actually puts out quite a bit of light. I might have that as like a lower like, you know, I have my bigger light over there. I could have this like over here on the on my parts container somewhere, up here on my parts container, and then I can have it lighting up the set, but not as much. So, you know, I don't put something that's really reflective, and it won't, like, you know, the camera won't overexpose it. So I'm gonna put the, make sure to put the resistor. Oh, you can make the resistor work in reverse. You don't have to the resistors aren't polarized. So that means if you hook it up to ground, the resistor to ground, it won't kill you if you hook it up incorrectly. Alright, I can't bring up the voltage anymore. I have it set to 18 volts now. And they're not getting any brighter. So there you go. I can hook up 1, 2, 3, 4, 5. I'll count that as 2. 4, 5, 6, 7, 8, 9. You can hook up about 10 LEDs in 5 volts at 0.1 amps. So there you go. Now I'm going to hook the, I'm going to turn up the voltage a little bit. Oh, I can't. As you see, if I bring up the current, they do get a lot brighter. Now I brought the voltage so low that almost all the LEDs turn on. So I'm gonna take this off. And I'm gonna hook up to this pole right here. So these LEDs are now not on the circuit anymore. So I'm gonna hook this LED up, and this one requires 7.4 volts. Kinda odd, but whatever. I don't need to put it on the breadboard. And if you're wondering, wait a minute, you're not putting a resistor in series with it. Well, this one has its own resistors inside of it, so I can bring the voltage anywhere from 7.4 volts anywhere up to probably about 12, and it won't hurt them. Well, anything 12, they might get a bit warm. So I'm going to turn up the voltage now. And as you see, I'm bringing the voltage probably. Alright, the LEDs should be coming on around now. Now? Oh, there they go. See, now they're a bit. This is 7.1 volts, and you see they're a bit dim if they're in the shot. Let me take the breadboard out of shot. Put these down with the magnet. Here are my magnets. And I do have more LEDs. Like, I have a LED light string full of LEDs. So I'm gonna place a craft magnet, which actually they work pretty good. And I can stick a magnet there. See? This is my own idea, actually. I've never seen anybody else on YouTube done this before. Stick a magnet and then put wherever. Now that this has to be a magnet, I'm using a cookie tray as a resistant. So yeah, they're never going to touch each other. So now I'm going to bring the LED up to working voltage. Alright, that's around 7.4 volts. There's around 8.5. And there's 9.5, which is probably around operating. Quite bright, eh? And that's, if you're viewing through a screen that's newer than like 2008-ish, LEDs are more than likely going to be using, you're probably going to be using LEDs. Now, older than that then uses something called cathode tubes. And what is a cathode tube, you might ask? Well, basically a cathode tube is basically this tube. You could find them in fluorescent tubes. Basically, it's the same thing, but it's really small. Like, really small. Like, what can I use to compare? I've actually opened one up before, but I don't know where I put it. Oh, here's one. I pulled this straight off a laptop. Here's one. I still have it inside of its protective thing, but this is what the cathode tube looks like. And the reason why they moved on is because this is so inefficient. It's really, like, horrible. Like, it probably takes almost triple the amount of power to run them than these LEDs will ever take. And you can't just directly shove this into the power supply. You have to crank it up to like around 3 kilovolts, and it maybe barely might turn on. Like you need a couple kilovolts. Anyway, there's it's tiny tube. There's tiny little tube in there. I don't have a high voltage supply, otherwise I would have turned it on. But that's what older ones do. The reason why they moved on is actually these are quite dangerous. These contain mercury, and mercury is very toxic to humans. So that they moved on to these much energy efficient, safe LEDs. So there you go. I think that's all I need to demonstrate. So this is Ninja Power, I think. I still don't know what my name is going to be yet. I think I'm going to make it the Ninja Power Tech or something. Well, this is the Ninja Power of Tech. Remember to favorite, like, and subscribe. And share with others if you want to. And remember, well, I need to come up with the slogan also. Ninja Power out.